Good morning, everyone. My name is David, and today I'm going to introduce you this paper, Sheina Myodocopa cypridinidate and Ostracod parasitic on the gills of the epaulette shark and Resilient ocellatum elasmor branching hemicididate. And this paper is from the International Journal for Parasitology. Firstly, we need to know what is ostracod. Ostracod is in a subphylum of Crustacea. So it is a crustacean, and it has 70,000 of species, but only 13,000 of which are extinct. And marine ostracods can be part of zooplankton or part of benthos. Also, we found some species in freshwater, and terrestrial species are known from humid forest soils. Okay. Ostracods are small, typically around 1 micrometer in size. Their bodies are flattened from side to side, protected by a fiber-like chitinous or calcareous bulbs or shield. In my opinion, it looks like a clam. No clam? You know clam? And then I'm going to introduce you cypridinidate. It's a family from Ostracoda. And the most important thing is that we need to know their feeding strategies. Their feeding strategies in general divided into three different types. One is collectors, predators, and scavengers. Collectors feeding on small particles of detritus from sediment. And predators are good swimmers and greedy carnivores. They like to eat large active prey, like fish larvae, like carpods. And scavengers feed on big particle of debris or the remains of fishes. Scavenging ostracods do not attack healthy fish, healthy fishes, but there have some exceptions. For example, the fishes are confined in cages would be attacked at night by scavenging ostracods. So, what's the big deal? 3 authors reported cases of so-called parasitism in cyprinids. And also, none of previous study of possible parasitism in cyprinids have investigated in the ostracod for its effect on the host issue. And then we examine the occurrence and distribution of Sheina orri. Sheina orri is the species we want to investigate, and is a species in cypridinidate. Lastly, we compare the feeding appendage of ostracods employing other feeding strategies. Feeding appendage is the limb of ostracods used to grab food. To begin with, animals are required. Epaulette shark collected by hand netting during low tide Heron Island Reef in Australia. We collect 28 adult sharks. And then other ostracods used to compare the feeding appendage were caught by deadfish traps and midwater trawl. Tasmania West Coast, also in Australia, and Bermuda. This is adult epaulette shark looks like. And then statistical posture helps us to examine the distribution of ostracods on gills. And we use the Crusco-Wallis one-way analysis of variance on ranks. It's used to testing whether samples originate from the same distribution. Lastly, we also need to prepare specimen, and we remove the gills, placing in 4% of formaldehyde in seawater. Next, examine each hemibrand, identify as the species we need to investigate, Sheina orri, and then a few ostracods were collected for light or scanning electron microscope. Lastly, additional ostracods were used to investigate morphological differences. In the aspect of histology, we have two important results. As you can notice in picture B, letter P means the grooves on epaulette shark's gill filaments, and letter B represents the shark's blood cells. And the blood cells and tissue debris of shark origin were often present between the two carapace valves of ostracods. Carapace is the left valve, and right valve plus right valve is ostracod's carapace valve. The two valves. I don't know what I'm talking about. And as a result, maybe ostracods would ingest these materials, blood cells, and tissue debris. But the mechanical damage caused by the attachment and feeding activities of Sheina orri is minor. This is very important. And then look at the fold in interventional septum. You can see these three folds in the gills of epaulette sharks, and as I just mentioned, the mechanical damage caused by Sheina orri is minor. So I hope you'll be convinced that the fault, we couldn't know the fault was a pre-existing structure used as an anchoring site or caused by ostracods actions. And next, as the aspect of morphology, we compare it with other ostracods feeding appendage. Look at the picture. Let's look at picture A, which shows Sheina orri's maxillular cloud. You can see its cloud is curved, and next is curved in this three way. And next, please look at picture C. In picture C, we can see the pad morphology at the middle of this setup. And the yellow box, this picture is the mandibular cloud of Sheina orri. And the yellow box shows the characteristics of Sheina orri clouds. And then picture B, we can see the pectinate teeth on a scavenging ostracods cloud. Scavenging ostracods. And picture D, let's look at picture D, which shows the mandibular cloud of a predatory ostracod. It is only slightly curved, and it is curve very heavily, slightly. And picture E is a mandibular cloud of scavenging ostracod. And you can see its lack of the pet morphology. It's very important. It is unclear as to how the pectina teeth absence would enhance the attachment of gill, of ostracods to gill, and which might be an adaptation is the pet morphology. Therefore, the pet will form a pincer-like structure, help it to grip the fish gill or collecting material on the gill surface. And lastly, we see a life cycle of Sheina orri. We only found adult ostracods on the epaulette shark's gill instead of early instars. The absence of early instars indicate Sheina orri only parasitic for part of its life cycle. So, in conclusion, although some of the functional morphology of the mandible and maxillula of Sheina orri might be might be effective for parasitism, but it is not the only one to suit parasite. And it's likely that parasitism within the Cyprinidinae has evolved as an extension of scavenging. Here's my reference, and thank you for listening.
Okay. QA.
Any questions?
Jay. Jenny. Sharon. Ian. Okay, in this order. Jay.
Slide, which slide?
Picture 15.
15.
Okay. Is that the sharks? Inside the sharks or the outside?
Picture B is the shark's filament. And picture A, C, and D is the shark's gill lamprey. Balls. Lamprey. Yeah.
Where is Gill?
Gill is the things that sharks used to breathe. You know, the gill, G-I-L-L. Used to breathe.
Is that clear?
Is that clear? Okay.
Okay. Jenny.
you mean that the code was a very simple structure? I couldn't understand.
Can you repeat your question?
Okay. Can you speak louder?
Sorry. What do you mean that the code was a very simple structure? I
The
couldn't.
code was,
What do you mean that?
the code was a pre-existing structure.
Yes.
Oh,
Like I just mentioned, because the mechanical damage caused by the attachment and feeding activity of Sheina is minor. So this structure we didn't know, we couldn't know. It is a pre-existing structure used by the ostracod used to anchoring themselves, anchoring
Anchor.
to make themselves solid in the not solid to can I speak Chinese 2 words 固定
To fix.
to fix themselves in a gill filament or just pre-existing or just ostracods activities impact these shark gill filaments to have a fault. We didn't know because it's no response of sharks health issue. For sharks, health issue. Yeah. For sharks, it didn't matter.
Okay. Sharon.
What is this
BMP means
Where is BMP?
you say letter P and letter B means. Okay, letter P means the groove is like a hole, a hole like on the gill's filament. Because the ostracods will pinch the gill filaments to anchoring or grab it to eat. So it causes the hole, the grooves on the surface of the gill. And letter B represents the shark's blood cells and tissue debris. Letter B means. Is it clear?
Okay.
Thank you.
Good. Ian.
What is the purpose of this research?
Can you repeat his question?
What is the purpose of this paper? This question is very excellent. Maybe the authors have interested in this because he says none of previous studies of parasitism to research to investigate this topic before. We know ostracods are zooplankton, right? But we didn't know it will parasite in the animals. So I think the author have an interesting on this topic. So just do it.
Yeah, I think it's a nice defense. Okay. Volunteer question. Any? Volunteer? Bonus granted? Volunteer? No? Very so well. No question. No? No? Okay. Okay, so David. Okay. So I will start with the major criticism, which would be when I was looking at the paper yesterday. I think you chose a nice paper because if you present it well, it will be a real eye catcher. And today I will give you, I think you did not make the maximum effect out of it. The reason is, if I were you, I would definitely, let's see, okay, enlarge each of these figures. Make it full screen, for example. Maybe this one is not that shocking, but maybe this one will be shocking. You know? Because many people like me are very uncomfortable with things like insects. So when you see things like this, you will start to think, ooh, what's that? Yeah. And when the figures, the images are small, they are not as shocking as they are a full screen image. So next time, I will highly recommend you that, I know that you start with this one, right? And then this one. But I'm not sure if you ever explain this one. So if I were you, I will first show a full screen of this figure. Maybe in that way the blood cell can be seen clearly. I'm not sure. Yeah, because here I can barely see any blood cell here. I just saw some roughness. 一些粗糙的表面. I don't know what is that. So if you enlarge that, and then you just label blood cell next to the B, you just write blood cell here. Then it's very clear. You don't need to cross-reference here. And the same applies to the previous talk by Eric. So you just enlarge and then you print your label next to the symbol here. Okay? Okay, so enlarge your figure because they are really eye-catcher, especially for creatures like these ostracods. They are unusual. Okay. Okay, so enlarge your figure. And then again, here, I think in this figure, I think you have a lot of animations, okay, which is fine. However, starting from somewhere, you start to say, this is this parasitic ostracods, and then some of them are predator maybe, and some of them are collector or scavenger. But because you didn't print any keywords, I sort of lost, especially when you were keep talking. Line after line, I couldn't follow which one is which. So please, maybe at the beginning you enlarge these two so that their feature can be clearly seen, like what is the path here. And then you can show this comparison in a second slide. It doesn't need to be that big, but maybe for our row here, it should be very big. Okay, and then these are key criticism. And then the good thing about your presentation is, I think in your presentation, I can see complete, but of course it can be improved. There's a complete flow of logic, starting from data, and then come to conclusion. Yeah. Of course, the paper itself is a simple paper, but that's what I want to see. You have to draw your conclusion from your data, and your data need to be well explained. Okay. So that's the good part of this presentation. So now I will go to the beginning and show some minor comments. Okay, so here it's okay. For example, if I were you, I will be alerted by a new word like this. I wonder how many students here know this term, extent. What's extent?
先生重，
What?
先生重，
现存 okay? 现存 Okay. And then at some point, I was thinking you should use your pointer wheel, but you use your pointer wheel when you are talking about your data. Okay. And then there was a comma error here. How do you read this? This. Micro is 3 orders of magnitude smaller than millimeter. So this is millimeter. Okay? Milli is a common error. Okay? And then here, I also feel you have too many scripts. I also think in your introduction, you can make it more interesting by adding more image. It can be small image like what collector eats, what predator here, and then scavenger, etc. Okay. How do you pronounce this? Okay, now it sounds correct. Okay, as I said, more image. Okay. For example, what is appendages? Maybe you can give us a figure and then that's clear. Okay. And then usually for slides, technical slides like this, I think the previous 2 speakers did it well. I will convert the whole slides into images, figures, no text like this. Okay. Okay. Okay, so I'm almost done, but it's a good talk. Thank you. So let's take David.